Greetings class, Mr. Munir here with your next Coder Z lesson of the day. So we did Dangerous Curves 1 last time, now we're on to Dangerous Curves 2. And the cool thing about this one is now you get some tools that make life way easier. So sweet. Now we're still going to be using the gyroscope, but we're going to be doing something a little bit different. I'm going to go through these lessons. I'm not going to have you guys do Star Trail. It's just a lot, and you can do it if you want to, but I'm not going to make you do it. So where you guys are going to end is on S turn. Okay, and I'm going to do all these for you. You're going to do S turn. That's going to be your activity. So let's take a look at what we've got going on. And again, we're going to start with our lesson plan. All right. So again, we're doing turns, but we're going to add some tools that make our life easier. So lesson 5, Dangerous Curves 2. Last time we did the gyro sensor, screw turns, and pivot turns. We learned the robot can perform various types of turns, use the gyro sensor to know when to stop turning. That gyro sensor tells us the angle. And remember, clockwise makes it go up to positive angles, counterclockwise is subtracting, makes it go negative. And we can created a closed loop control block using a wait until gyro block and took into account the robot's momentum, which carries it a bit further than we intended. So that was like that overshoot. What have we got today? The turn to block. That's going to make life easier. And the last thing is smooth turns. Okay. Last time we created a complicated control block using a wait until gyro block and a compare block, and then told the robot to break it once it reached our desired angle. It's hard to turn accurately with this type of code because you're overshooting every time, and it's like you would never want your code to be like that. You would never in real life want to control a robot in such a way that there's this variability, like, oh, it's going to overshoot by who knows how much, but it'll get close. You'd never want that. So it's not accurate. So what do we have now? The turn to block. So how does this work? We've learned that there are three basic, oh, did I skip something? A tip for you now. The turn, oh yeah, meet the turn to block. Okay, turn to 135 degrees. This block executes a perfect screw turn to the exact angle we specify without the need for a modular control block. Behind the scenes, this block performs a complicated control loop, turning slowly, and constantly sampling the gyro readings until it reaches the degrees you want and stopping exactly there. So what this does is it actually just does a regular screw turn, not a pivot turn, a screw turn, and it turns it exactly to the degree that you want it to turn to. Perfect. So you don't have to worry about overshoot. You don't have to worry about anything like that. So yeah, cool. So that's just way better. And we're going to work with that. So there are three basic types of turns. There's a screw turn, where it just like turns on a dime, basically. There's a pivot turn, like in basketball, where you're pivoting, you have a pivot foot, and then you turn. Right now it's time to learn about the final type, smooth turns. Now remember, screw turns, you have one going positive, the other one going negative. Pivot turns, you have one stationary and the other positive, and it turns towards the stationary wheel. Now we're learning about smooth wheels, or sorry, smooth turns. And this is how this goes. Instead of one wheel being stationary, they both move, but the outer wheel turns faster than the inner wheel. And this is how a car turns. Okay, generally speaking, your car wheels don't go in opposite directions. You don't have one stationary and the other one going. No, generally speaking, you'll have the inner wheels going slower than the outer wheels, and you turn smoothly in a car. So this is much more like you guys are probably used to a smooth turn. So in this case, the slower wheel is the inner wheel, and you'll turn in the direction of that slower wheel, and the outer wheel is the faster wheel. Okay, so let's be clear, like just to go through it, the pivot turn, one was negative and the other one was positive. I'm sorry, the screw turn, one was negative, the other one was positive. The pivot turn, one was 0, the other one was positive. This turn, they're both positive, except this one is slower than this one. So you can see that it's kind of like this scale from screw turn, pivot turn, to now smooth turn. Okay. How do we do this in Coder Z? There, boom. Set wheel speed left 20%, right 80%. So right's going to spin faster, so you're going to turn to the left, because the slower wheel is the inner wheel of the turn. Awesome. Cool, playtime. All right, let's do it. So let's take a look at N curve. I'm probably just going to skip over M curve because I'm not going to have you guys do that one. Let's take a look. So how do we do this? I'm going to actually go ahead and restart this mission because I already did it. And you're going to see that this is so much easier. If you just took a look at the code, it's just way easier. So Ruby needs to go through N again, but we'll be using the new block to simplify screw turns. We use the turn 2 block. And, oh wait, let me see. So it's a special block that makes Ruby accurately turn to whatever angle you put in by turning with proportional power. This means the further away from the angle, the faster Ruby turns. The closer to the angle she is, the slower she turns. So if you tell her she's got to turn 270 degrees, she's going to start off fast. Robo's going to start off fast, but then as it gets closer and closer to 270 degrees, it's going to go slower and slower and slower. So that's how it's able to turn very accurately, so it doesn't overshoot at all. And then actually what you'll find is if it does overshoot, it'll turn back. So if it overshoots, it'll turn back to go to where it needs to go. So very, very cool. So explore mode, check your angles, heads up display, will do. Okay, so let's bring our gyroscope out. Let's go here. Okay, so we're starting here, and then let's figure out the angle that we need to turn to. Okay, so first we'll figure out our distance rather. So we're gonna drive straight ahead a distance of 8 meters. So this says 750 centimeters, and then turn to 135 degrees. Okay, well, let's see if that's correct. So start with this heading, and then I'm going clockwise, which is positive 135. Cool, that looks good. All right, so let's see how this works. Let's go ahead and hit play. Let's see if this does the job. Cool, it went the right distance, nice. Watch the gyroscope. Oh, it overshot and it turned back to 135. Cool, that's exactly what we wanted it to do. So that's it. I mean, that was much easier. As you can see, instead of doing this crazy amount of code, we just use this turn to block and we're done. All right, so then the next distance, let's find the next distance that it's got to go. It's got to go 11.5 meters. Okay, so I'm going to duplicate that. So we'll say 1150, that should work. Now, cool, let me check this out. So I want to reset the gyro. Why? Well, because remember when I said in the past video, hopefully you've watched it at this point, that like if I don't reset the gyro, then I'm going to end up having to add or subtract every time I have a new turn, but I don't want to do that. I just want to be able to like figure out how much I'm going to turn each time and let that be that. So I drive a distance, I turn 135 degrees. Once I've turned 135 degrees, I reset the gyro, and then I drive a distance of 1150. And now I should be at this point here. So I'm going to be in this heading. Oops, sorry. So I'm going to be going this direction. That looks pretty good. And I'm going to go counterclockwise, remember. Okay, I'm starting in this direction, but I'm going to go turn counterclockwise 135 degrees. So I want to now turn to negative 135 degrees. Cool. Once I've turned there, I can just go ahead and drive that final distance, which should be easy to find. We'll call it 8 meters, sure. So data, 800 centimeters. Now remember, if you don't reset this gyro, then I would have ended up actually turned to 0 degrees because this heading and this heading are the same. And if you don't reset the gyro, the way that it reads the angles is going to be relative to your original heading. So I'm originally heading in this direction. So if I don't reset it, then I would have turned to 0 degrees. But I like to reset the gyro because then it's obvious. It's not like I'm just turning 0 degrees. No, I have to turn 135 degrees counterclockwise. So let's go ahead and hit play and see how this works. So I drive my distance, turn to 135 degrees, watch that gyro. Sweet, it overshot but turned it back. Now it's going that final distance. Oh, 1150. Oh, I went too far. Okay, so I'm going to reset the simulation. And I'm going to bring this down to, let's just make it 1100. So, went too far. No big deal. Okay, so drove 750, turned to 135 degrees. Now I'm going 1100. Sweet, that looks good. And now, boom, negative 135. Okay, and if you saw it, it actually reset. Let me just point this out really quick. So that worked, obviously very good, but let me point this out. So watch for the moment that I actually go ahead and get that code where it resets the gyro. So look, it starts turning, 135, boom, it got reset to 0 degrees. So this is my new 0, it's my new heading, and that enables me to just say, okay, I know that I'm going to turn 135 degrees counterclockwise. So that's my new heading. And notice that it's perfect. It doesn't overshoot at all. So cool. All right, so the next activity would be M-curve, but M-curve is basically the exact same idea as N-curve, just harder and longer. And you know what? There's not really a whole lot of point in me going through it, but I already did it, so let's just take a look at it. So in this case, I actually didn't go ahead and reset my gyro, so it actually is a little weirder, right? So it turns counterclockwise 145 degrees, and then it's going to turn until it gets to this new heading of negative 30, and then it's going to turn again till it gets to this new heading of 180. There you go. See, but like, to me, it's really confusing because it doesn't actually turn 180 degrees, and that's really confusing. So I think I'm actually going to go through and reset the gyro and see what that's going to be like. Okay, so I'm going to reset the gyro after every turn. Obviously, I don't have to reset it after the last turn because who cares? I'm not going to use it again. Okay, so my first angle is going to be correct because I started at 0, so that's 145, good. But now my new heading is in this direction. Does that look pretty good? Notice that the longer I make my line, the easier it is to tell if I'm like going in the right direction. So it's like, okay, nice, make it nice and long, make sure that you're going in the right direction. And then I'm turning clockwise, right? Because that's the same way a clock would go, like this, right? Turning clockwise, and it looks like a heading of 120 degrees. So I reset my gyro, so now instead of negative 30, which doesn't make sense because I'm not even turning counterclockwise, I'm turning clockwise, right? I'm going to set that now to 120 degrees clockwise, cool. And then I can always go to full screen. That didn't really help me in this case, but okay, so I'm going to go back to the screen, and then let's see my final heading. So now my final heading, I was going in this direction, something like that. And then I'm going to turn counterclockwise. Notice that I'm turning counterclockwise to get to my new heading, and that's 145 degrees. Cool. So I reset my gyro, so it's counterclockwise negative 145 degrees. Okay, so now this makes a whole lot more sense. This shows me I turn counterclockwise 145 degrees, then I turn clockwise 120, and then counterclockwise 145 degrees. When I look at this code, it's way easier to make sense of it than without resetting the gyro. So let's just go ahead and test it out to make sure that I've got it right. So I go the same distance, counterclockwise turn, should get to negative 145. It does, and then it resets. Then I'm going, now it should go clockwise 120 degrees. So I do, and then it resets again, because once I've turned, I'm good. Oh, okay, so that actually didn't need to go 120 degrees. Either my distance was off or whatever, but it looked like it could have just gone like 115 and would have been better because the angle looked like it was a little bit off. So there you go. So you tested it, you found out that it didn't quite work, and you try again. And I really like this overhead display, especially when we're turning, because it makes it easier to see the angles that you're turning through. So there you go. Turn negative 145 degrees, go forward. Then it turns through 115. Yep, that angle looks a lot better. Good. Reset and then 145. Oh. And so there you go. That angle wasn't enough. So actually, I'm going to go ahead and turn that through negative 150 degrees because that clearly didn't turn enough. Now, one last thing I want to show you guys is if you want to speed things up, you can do twice speed or even 4 times the speed. And if you just had a simple mistake and you don't want to sit there and watch the whole thing, then double the speed or even quadruple the speed and the thing starts going pretty fast. And you spend a whole lot more time just watching your robot move. Sweet. Awesome. Cool. That worked well. All right, let's see how we're doing on time. Okay. All right, so 17 minutes in. No, I would not like to resume where I left off. Dangerous Curves 2, Part 2. Okay, so this is where I'm going to leave you off for this video. After I'm going to do this, we're going to go through U-turn, and then I'm going to tell you what it is that you're going to be done with. Okay, so if parents ever done a U-turn in the car, basically it's a situation where we're facing one direction but need to face the other way. So it's an upside down U. Cool. U-turn. Here's what a U-turn would look like with our robot using a smooth turn. Cool. Nice, and the robot goes through. Very nice. I think I skipped ahead, so it's probably not going to let me run through it. Okay, it's showing it again. What is the angle the robot is turning to during this turn? We start by driving forwards. So we start going this way and then we end up going this way. So that's clearly a 180-degree turn. Draw an arc to find the angle. It was 180 degrees. Then after that, if you want to do an S turn, it's like a U-turn back to back. First up, 180-degree angle, just like the U-turn. Goes through it. And our next turn is 180 degrees again, just the other way around. So an S turn is basically just a U-turn back to back. Cool. Don't forget, when turning, momentum will carry the robot further than we intended. Okay, so now remember, turn 2, that turn 2 block only works for screw turns. So that's not going to work for like the smooth turn that we're going to be doing now. Okay, so we have to remember that. Okay. All right, so I'm going to do U-turn, and then it's going to be up to you guys to do S-turn. I'm going to walk you through the basics of it, and we're not going to do these two. Okay. So let's make it through. All right, so I'm going to restart the mission just to show you how I did everything. All right, this time Ruby needs to perform a smooth turn. Smooth turns are done by giving more power to one motor than the other. Use this wait until block to keep turning until the gyro is greater than or equal to 170 degrees. Taking into account the time to slow down, Ruby should end up turning to 180 instead. Okay, gyro y-axis. Look, I'm turning clockwise, so it's got to be greater than or equal to because the angle is going to keep going up. It says 170, cool. Now, it's got the wheel speed at 100% and 75%, but to me, it just makes a whole lot more sense to just go slower. So drive distance this much, then turn through, wait until this, and then it's gonna, so this is just gonna drive up a little bit because if you notice, it doesn't actually start right at the turn. It goes forward a little bit first, and then it starts turning, and then after it's done the turn, it goes forward again all the way to the target. So let's see if this will work. So I go forward. So it drove my distance. And now I see that that turn was too tight. Okay, the turn was too tight and it overshot. So I need to make my turn not as tight. Okay, a little bit looser of a turn. So how am I going to manage that? Well, that's a really good question, and this goes into exactly how this works. So the faster my outer wheel turns, the tighter the turn's going to be, and the slower. So the bigger the difference between my inner wheel and my outer wheel, the tighter the turn. So if this is going fast and this one's going slow, it's going to be really close to just a pivot turn, which is just like turning real quick. But if they're both going the same speed, look, like if I just make this like it's 18 or something, watch what happens now. So the first one, it was 20 and 10, so it was like double the speed, but now it's just like barely any difference. Okay, so it went forward, and now it's wanting to do my smooth turn. But look, now it's much looser, you see? So it's not as nearly as tight of a turn. So it's got to be somewhere in between there. So I can keep my left speed at 20 and then just adjust my right speed to just get that turn dialed in exactly how I want it to be. So let's try 15. Okay, and let's take a look at our gyroscope to see what angle it stops at to make sure we're not overshooting. So it drives that distance. Now it's starting to turn. Cool, nice. It's dialing it right in, and it overshoots a little bit. And why did it overshoot? Well, I'll tell you what. What should I have done? I should have after. Oh, never mind. I was gonna say break until stop, but it overshot to be like 194 and I only wanted it to be 180, so I'm actually going to bring this down to 160 and see if that works a little better. So let's take a look at that now. I still won, I still got everything, but you know, it's nice to just explore this to make sure that we're doing the right things and we know how to do what we're doing. Okay, so now watch that gyroscope. So it's got the turn dialed in, and this time it stops at 185, 187. Okay, cool. But much better. Before it was 197, now it's 187. Cool. Cool. Awesome. So that's the U-turn. All right, so now we're going on to the activity that you guys are actually going to have to do. This is the first thing that I'm actually asking you to do on Coder Z on your own. Okay, so let's take a look. All right, let me restart the mission. All right. Okay, this S curve is like a back-to-back U curve, hint, hint. Okay, here's some code for a U curve. Add and configure more blocks to solve the mission. Got it. Okay, so first you're going 100 and 100%, 100%. Wait for 2500 milliseconds. Then you're going to start this smooth turn. You see the left is going faster than the right, so it's going to turn to the right. Wait until it's greater than or equal to 170. Then it's going to go forward again. So here's the idea. You're going to go forward, you're going to turn, you're going to go forward again, and you're going to turn and then go forward again. Okay? So now let me give you some pointers. First off, let's see what happens when I do this right now. Let's see what the problems are with the code that they've provided to us. Okay. Yeah. Lots of problems, very clearly. Okay, so that's supposed to be a U-turn that like ends up with us, doing something good, but the rotation is supposed to be 180, way overshot. And why? It's because it's going too fast. So the one pointer I'm going to give you is bring this down to like 20, okay? And then bring this down to the thing that we know, 20 and 15. And now and then last time it overshot, so let's make this 155 this time because it still overshot last time. So I'm going to hit stop. I'm going to reset the simulation. So those are the pointers I'm going to give you, and then we'll see. Again, you're going to have to slow this down too. Let's just see if this is any better. Okay, so went forward, waited. Now it's got my turn. Okay, and then all right. So that's still not quite it. But I want that at least to work for you guys before I just drop you off a cliff here, though I think you can do this on your own. Let's make this 3500, and then bring this down to 20 and 20 again, right? So at least the code they provided, we're just adjusting that, and then you're going to have to do that last little bit by yourself. Okay, so I'm moving forward. Now there I am in my nice smooth turn dialed in. Let's check our gyroscope. Awesome. So this one stopped at like 155. So that isn't quite exactly how I wanted it to be. And then it went forward. Okay, so it overshot it by a lot less this time. So I'm going to make that 165. And this is the last thing that I'm going to do. And let's take a look. Let's see how this works. Okay, so it went forward the right amount of time, then I've got my curve. Boom, stopped at 172. Cool. Now, clearly, there's much more to it, okay? So, you know what, I said it was the last thing, but let me just do this little bit just to make sure that I don't leave you in a bad place. So I think this will look a little better because it was kind of it was undershooting the turn a little bit, so I want it to be right on the line before I give it to you as a solution. So there you go. That looks better. Okay. Nice. There you go. All right. So cool. So now clearly, where did I leave you? So, whoops. Oh, I had it twice, so it thought I wanted to play it again. Okay, so it went forward, then it turned, and then it's going forward again. This may or may not be necessary. You might just be able to go right into that U-turn. So you might end up deleting these blocks, but you're going to have to do a U-turn now. But you're going to have to go now, instead of going clockwise, you're going to have to go counterclockwise. You're not able to reset in this one. So if you're going counterclockwise, you're going to want to end up at a heading of 0 degrees, right? Because look, if I go to my overhead view, I start off going this way, I turn 180 clockwise. That's going to be, if my gyro is going to be at 180, but then I'm going to turn again and my final heading is going to be 0 because I'm going 180 degrees counterclockwise. So it's 180 minus 180 is then going to end up as 0. So my final heading should be wait until get gyro y-axis is less than or equal to some value like 10 or 15. So it stops at 0. So that's pretty much it. If I give you anything more, I'm just doing it for you, and I don't want to do that. So this is your assignment. Get this done. Have this completed, and that'll be it. Just to give you a heads up of what we're going to do next, let me go back to the Learning Center. So we're going to go ahead, we're going to skip this because that's just about learning how to do trails and things, and that's cool, but I just, you know what, forget all that for now. Let's go to touch, avoid, repeat. So touch, avoid, repeat is going to be the next set of lessons that we're going to do, and this is where we're going to start learning about loops and how to use our loops in good ways. Okay, so that's it. Your assignment is to do S-curve. Get that done. Okay, that's the assignment. All of the points for that homework assignment is going to be in getting S-curve done. All right, that's it for me for now. Until next time, enjoy robotics.